This is for Year 12 Specialists. It comes out of 2C. It's question number 17. It's involving a scalar product, but also a proof. The proof is we need to show that diagonals DB and CE bisect each other, and we need to find the acute angle between them. Okay, so this is going to be my DB, and this is going to be my CE. I'm going to say that they intersect at point M. And for the second part, for the acute angle between them, I know that for the dot product, I can get an angle. So the vector dm dot the vector CE will equal the magnitude of dm times the magnitude of CE times the cosine of the angle between them. So that's the dot product rule. Therefore, the cos of theta will be dm dot CE over the magnitude of dm over the magnitude of CE, and then I can use my calculator to take the inverse sine of that and find the angle. Now it's asking for the acute angle. If the dot product is negative, it will give me an obtuse angle, so I can subtract it from 180. So I'll show you how to do that one in a minute. The second one is to show that this is a bisection. If it's a bisection, then it cuts this diagonal in half. Therefore, D to M magnitude is equal to the magnitude of M to B, and it cuts both of them. So this one is the same length as this. So I've got to prove the magnitude of dm equals the magnitude of mb, and that the magnitude of cm equals the magnitude of me. Or the other way that I can do it is that I can say I have a scalar. The dm is some scalar u of dB. That is, that it's a scalar along this diagonal, and that cm is some scalar v times CE. Now, if it's a bisection, therefore u should equal a half, and v should equal a half. Now, if I'm showing this the case, I can't use it. I've got to come up with that myself. So I'm going to use this method. I'm going to get an expression for OM going along through D, and an expression for OM going along through C, and set them equal to each other and find what U and V are. Okay, so that's my method. Dot product to find the angle, and I'm going to get a chain of vectors and set them equal to each other. Okay, so this is what the solution looks like. Okay, I'm looking for my dot product. I've worked out what dB is by a chain of vectors, D to O, O to A to B. A to B is the same as O to C. So I've replaced A to B with O to C. That's those vectors, and that's what dB equals. I've done the same thing with CE. To get from C to E, I've gone from C to O plus O to A, and then I've used O to D because A to E is the same as O to D, and I've come up with that vector. I've worked out that the magnitude of dB is root 38, the magnitude of C is root 14, the dot product is -8. Then I can rearrange my dot product and come up with my angle being 69.7, and this was a negative, therefore the angle that it gave me was the obtuse angle. Okay, To do the second part of this, I've set up my d to m is u times d to b, and c to m is v times c to a. If I can find that u equals a half and v equals a half, therefore it's a bisection. So I've got my O to M, which is going through D, and I've got an O to M, which is going through C. So this is my O to M going through D. This is my O to M going through C. So I can equate the I components equal to each other, which gives me one equation in terms of U and V. I can equate the J components equal to each other, so I get an expression in terms of U and V, and I can equate the K components. Now you notice that this is the same as this, so U minus 1 equals negative V. Rearranging this equation, I can do a substitution into this equation. 5U plus U minus 1 equals 2, 6U equals 3, U equals a half, and since U plus V equals 1, V also equals a half. Therefore, they bisect each other.